Everyone, in this video we are going to solve this question, which is next smaller element. This question is also known as help classmates. So basically in this question we are given with an array, and in this array we have to find the next smaller element for each element. For example, for 3, the next smaller element cannot be 8, cannot be 5, as 8 and 5 are greater than 3. So 2 is the next smaller element, right? So the answer would be 2. Now for 8, the next smaller element is 5. The answer is 5. For 5, the next smaller element is 2. It's 2. And for 2, there is no next smaller element, as array gets ended here and the element is greater than 2. So we'll just put -1. For 25, there is no next smaller element. We'll just put -1. Right? Alright. So we can have two approaches over here. One of them would be brute force. Let's go ahead and write this array. So 3, 8, 5, 2, 25. 3, 8, 5, 2 and 25. We have this array over here, and what we can do over here is, for each element in the array we can check all the next elements of the array and find the next smaller element. So for 3, we'll go ahead and iterate the rest of the array. We'll go on to 8. Is 8 smaller than 3? No. Is 5 smaller than 3? No. Is 2 smaller than 3? Yes. We can store 2 into our answer vector. For 8, is 5 smaller than 8? Yes, we can store it into our answer vector. For 5, is 2 smaller than 5? Yes, we can store it into our answer vector. For 2, we don't have a smaller element and array gets ended. The next element is not smaller than 2 and the array gets ended. So the answer which we'll store would be -1. For 25, the array has ended. It is the last element. The answer would be -1. Now what is the problem in this approach? In the worst case, for first element we have to iterate the rest of the array. For the very first element we have to iterate the rest of the array, and the time complexity would be n square, right? Because we have to reiterate array each and every time, right? If the array would be in ascending order, it would be the worst case for this brute force approach. So what can be another approach? We can use stack, right? Let's see how we can use stack. For example, we have 3, 8, 5, 2, 25, right? We have this array. What we can do is, we can store the minimum element. We can store a minimum of negative element. We cannot have negative elements in this array. The minimum element, we could have also stored int min, but if we have not found answer of an element, then we have to store -1. So why not just store -1, right? So let's go ahead and make a stack. All right. So just a sec. Okay. All right. So for example, this is our stack. Right now in this stack, we have initialized this stack with -1, right? What we can do is, if we iterate from left to right in this array, we could never find the next smaller element in a concise time complexity. What would happen is we have to again reiterate the array. But if we iterate the array from right to left, then we can find the solution of this problem in O of n. Let's see how. All right. Now we have figured out that we have to traverse the array from right to left, right? So we'll go on to 25. And we'll see if 25, which is the current element, is greater than the topmost element. If the current element is greater than the topmost element, then the topmost element is the next smaller element, right? If current element is greater than top element, then top element is our answer. It is smaller, right? So over here we can see current element is greater than the top element. We'll have an answer vector, right? We'll push the current element into stack, and we'll push top element into answer. So right now our answer vector has -1. Which is the answer for this. which is answer for this, right? All right, now let's check the next element. Also we have put 25, right? We have put 25 in the stack. All right, we have put 25 in the stack. Now we have 25 in the stack. Now we'll go on to next element. We'll check, is the top element less than the current element? No, so it is not the answer for 2. What we can do, if current element is actually smaller than the top element, which means top element is greater, not our answer. What we can do is we can go ahead and pop 25. We can go ahead and pop 25. Now we will check, is -1 less than 2? Yes, -1 is less than 2. So the answer for 2 would be -1. We can go ahead and push it, right? All right, now we'll go on to the next element. And also when we have popped 25, we'll remove this 25. We do not have 25 anymore, but we will push 2. We have to push each and every element into our stack, right? We have to push each and every element in our stack. So we have 2 over here, right? We have pushed 2 into our stack. Now we'll go on to the next element. Now we'll check, is the top element less than the current element, which is this? Is the top element less than the current element? Yes, so the top element is our answer. We'll push top element. Top element is 2. We'll go ahead and push top element and we'll do nothing. We'll just move on to the next element, because this top element can be answered to some another element also, right? This top element can be answered to some another element also. So we have pushed 2 into our answer, which is the answer for 5. Now we'll move on to 8. Also we have to put 5 in our answer, in our stack, right? We are pushing elements in each and every case. In both the cases we are pushing elements. We're pushing elements in the stack. It is a different thing that we'll pop the elements in this case, but we are pushing elements, right? All right, so now we have gone to 8. Now we'll check, is top element less? Yes, top element is less than the current element, so the top element is the answer. We'll just simply push the top element into our answer and we'll push this 8 to our stack. Now for 3, we have moved to the next element, which is 3. We'll check, is top element less than the current element? No. This case we'll pop 8. Now we'll again check, is 5 less than 3? No, we'll pop it. Is 2 less than 3? Yes, 2 is less than 3. 2 is our answer. We have gone to this case, 2 is our answer. We'll just simply put 2 in our answer. This would be our answer vector. Now if we have to return this answer vector, we cannot return it like this. We can reverse it. Reverse and return answer vector. But what else we can do is, instead of reversing the whole answer vector, what else we can do is, in the first place only we can create answer vector of size n, and the element for which we are checking, we can access that particular index in our answer vector and put the answer for that in that index. Let's see how. Let's go ahead and code this, what we have found the ideal approach. Let's go ahead and code it. So first of all, we have a stack, right? We have a stack of integers. Let's name it as st, and we have a vector int answer, and it can be of size n. As we are given a size n, which is size of array, and answer vector would be of same size of array, right? We'll have size n. Now what we can do is, we have help classmate function over here. What we can do is, we can iterate over the array. We can iterate from the last element of the array, right? We have to iterate from right to left. We'll go ahead and iterate from array dot size -1 greater than 0, and we'll move from right to left, I minus. What we can do is, we can compare the current element. If the top element is smaller than the current element, top element is answer. We'll go ahead and push the top element. Or what we can do is we can simply just access the index of answer and put the top element in that, right? Put the top element in that. And what else we have to do? We have to also push the current element into stack, right? We also have to push the current element into stack. Else, if this is not the case, what we'll do is we'll pop out unless we find a smaller element, right? Until we'll pop out until we find a smaller element, while we have a greater element in top. We'll pop out. Until then we'll do st.pop. Until then we'll do st.pop, and once we have found the top which is smaller, we'll just simply put it into our answer vector. We'll simply put the top element into our answer vector, and we'll push the current element. Right? And let's go ahead and return our answer vector. All right, segmentation fault. First of all, we have to handle the equal case also, because it is not written anywhere that will be strictly smaller. We have to handle this case also. Now let's see what's happening over here. Okay, else a vector of int of answer of size n. Okay, while the top element is greater, we'll pop it. Okay, we have not initialized the stack with -1. As I told you that we have to initialize the stack with -1, right? We have to initialize the stack with -1. We have not done that. Now also our answer is coming wrong because it is not working for the first element, because we have not included 0 over here. Once we include it, it will run. Yeah, let's go ahead and submit this. All right, so 1 3 1 1 1 1 1 -1. Okay, we do not need to include this, but until the top element is greater than or equal to, I think we have to include it over here. Let's go ahead and submit this. Top element is greater than or equal to, we have to pop it. Yeah, right. All right, so we have solved this problem successfully. Thank you.